Today is the 25th of September 2015 and we are the Group 7 for LAX2027. I'm Akinjan with the metric number of 183825.
I'm Tushan Hamluchan, metric number 181290.
My name is Siti Suhaila Muhammarov and my metric number is 181636.
Okay, my name is Putri Sabrina with the metric number of 182201.
My name is Ami Abdul Rahman. My metric number is 182082.
And my name is Dong Wei Sheng, metric number 181588.
Okay, so today we'll have the first LAX activity to discuss about why do we use spectrophotometry in biochemical assay.
Let's see.
Okay, so we'll start off with a discussion on what is spectrophotometry.
Okay. Generally, spectrophotometry is defined as the quantitative measurement of the refraction and the transmission properties of a material as a function of the wavelength. Okay, the spectrophotometry theory uses photometers that can measure a light beam's intensity as a function of its color, also known as the wavelength, known as the spectrophotometers for the device. And this device has the important features of spectrophotometer, spectral bandwidth, which is the range of the colors it can transmit to the test sample, as well as the percentage of the sample transmission and the range of the sample absorption, and sometimes also a percentage of reflectance measurements.
Okay, spectrophotometry is a method to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light passes through the sample solution. The basic principle is that each compound absorbs or transmits light over a certain range of wavelength. The measurement can also be used to measure the amount of a known chemical substance. Spectrophotometry is one of the most useful methods in quantitative analysis in various fields such as chemistry, physics, biochemistry, material and chemical engineering, and clinical applications. So we'll continue with the function of spectrophotometry. Anyone of you have any idea about this? Example of an experiment in which spectrophotometry is used is the determination of equilibrium constant of a solution. A certain chemical reaction within a solution may occur in a forward or reverse direction where reactants form products and products break down into reactants. At some point, this chemical reaction will reach a point of balance called the equilibrium point. In order to determine the respective concentrations of reactant and products at this point, the light transmittance of the solution can be tested using spectrophotometry. The amount of light that passes through the solution is indicative of the concentration of certain chemicals that do not allow light to pass through.
Consists of a light source, a collimator, a monochromator, a wavelength selector, a cuvette of sample solution, a photoelectric detector, a digital display or emitter. A spectrophotometer consists of two devices, a spectrometer and a photometer. A spectrometer produces a desired range of wavelength of light. First, a collimator transmits a straight beam of light that passes through a monochromator to split it into several wavelengths. Then, a wavelength selector transmits only the desired wavelength. After the desired range of wavelength of light passes through the solution of the sample, the photometer detects the amount of photons that is absorbed and then sends a signal to a galvanometer or a digital display. The use of spectrophotometers spans various scientific fields such as physics, material science, chemistry, biochemistry, and molecular biology. They are widely used in many industries, including semiconductors, laser and optical manufacturing, printing and forensic examination, as well as in laboratories for the study of chemical substances. Ultimately, a the spectrophotometer is able to determine, depending on the control or calibration, what substances are present in its organ, and exactly how much is through calculations of observed wavelength.
How to use a spectrophotometer? Firstly, of course, we must turn on the machine, and then we select the wavelength that is suitable for the test sample that we're going to test. And then in the cuvette holder, we place a cuvette that is filled with distilled water, and then we close the cover. And then the reading that is shown on the machine, we set it as a 0% transmitting, or which means there is no light is absorbed. So, and then after that, we just put in the test 1, which contains a sample, and then the test 2, which contains a sample, and then the result shown on the machine is what we're going to record, and that is what we're going to calculate on our experiment. Okay.
So, the spectrophotometer is also used in physics. In physics, the light is more to electromagnetic wave. It exhibits properties as post-wave nature, the visible spectrum effect, and particularly the photoelectric effect. Okay, so in the physics, there are formulas which is to calculate the transmittance. The formula is the transmitted intensity divided by initial intensity times 100% to get the transmittance. And the other formula is to calculate the absorbance, log transmitted initial intensity divided by the transmitted intensity. That's all.
The spectrophotometer works is based on a principle which passes a beam of light through a sample, and the transmitted light from the sample will be calculated. Okay, in every particles, certain wavelength will be absorbed by the particles, and this will cause the transmitted light by the sample to be reduced. And and the difference between the initial beam light and the transmitted reduced light, this will use to calculate the amount, the percentage of absorbance by the particles that is used as the test sample.
So what is the function of spectrophotometer? Okay, basically spectrophotometer is the device used in spectrophotometry. It measures the amount of light absorbed by the sample, whether it is liquid or solid. Okay, it measures the light intensity as a function of wavelength, and are commonly used to measure the concentration of aqueous compound in aqueous solution. It also, in spectrophotometer, the light passes through the sample, and the detector will measure the intensity of the light, and then it will change the light intensity into a numerical value, so we can measure the intensity of the solution. Okay, the light consists of photons and will encounter an atomic. Okay, there are different types of spectrophotometers depending on the different wavelength. So, for example, there are UV visible spectrophotometers which measure in the UV and visible regions of the electromagnetic spectrum. There are also UV visible near infrared spectrophotometers. It is typically measure up to 2600 to 3300 nanometers. Okay.
So as said before, the spectrophotometer, it passes a beam of light through a sample and measures the intensity of light reaching a detector. So here in the usual spectrophotometer, there are two configurations, which is a single beam and a double beam. So for the single beam, it is normally used as a reference standard to standardize the instrument by taking measurements. As for the double beam, the light will spread into two paths, and one will go through the sample and one will go through the reference standard. So I will compare between the double beam and the single beam spectrophotometer. As for the single beam, it is more compact and have a higher dynamic range. As for the double beam spectrophotometer, it measures light intensity ratio, and it is not as sensitive to fluctuations in the light source or detector. So there are also other types of spectrophotometer, which are fluorescence spectrophotometer and atomic absorption spectrophotometer. Do any of you guys know the bioassay application of the spectrophotometer?
The application in bioassays includes in the estimating of dissolved organic carbon concentration, specific ultraviolet absorption for metric of aromaticity, and also biosters for concentration of pentoses, and also included in determination of heart disease, which the enzyme concentration extracted from the patient is used to compare with the normal graph of the enzyme concentration.
For the discussion for today regarding the spectrophotometry, and thank you everyone for joining this discussion.
Thank you.
Okay, thank you.